This conference will now be recorded.
Hello everyone. Let us start with the PCI Express Gen 6 protocol training. This is a brief about what is the content that is covered as part of the Gen 6 training. So let's now go over the Gen 6 protocol training agenda. Initially, we'll be starting off with understanding the Gen 6 important updates, like what exactly is PAM4 signaling, and then what is the need for having flit mode and non-flit mode. I mean, what exactly is the flit mode? And then we'll talk about forward error correction concept. So these are some important updates. There are of course many other updates, but these are the significant updates. Then we'll be talking about Gen 6 topology, which includes multiple PCI domains and how do they interface. I mean, how do they connect in the system. Then we'll be understanding the transaction layer updates, where we'll understand the header format updates, the concept of deferrable memory write request, which has been introduced in Gen 6. We'll also talk about common packet header fields for flit mode and non-flit modes. We'll also talk about flit mode TLP header type encodings. You see, when we go to the flit mode in PCI Express, basically it can work in two modes. Either it can be working in flit mode or non-flit mode, which gets negotiated during the link training part. During the configuration phase of the LTSSM, the link will be either link will negotiate to work in either flit mode or non-flit mode. Accordingly, the what type of TLP header you will be sending will be decided. I mean, if you are in flit mode, a new type of TLP header format will be used. If you are in non-flit mode, whatever the one which we have discussed in Gen 5, that is what we are calling as the non-flit mode. That type of TLP header format will be used. So, as part of this transaction layer updates, we'll be understanding what are the updates that happen to the TLP header fields. Okay, so here in flit mode, there is no concept of format. There is only type, which is 8 bits. So that 8 bits will be encoded into different types of TLPs. So here we'll be understanding those things. And of course, we would also understand what are the different header formats for different types of packets. And we'll also understand the trailer size. Generally, whatever we call as digest or ECRC in till Gen 5, that is being called as a trailer. Till Gen 5, we had a provision only for one double word ECRC. Now it comes with a provision of multiple double words. So we'll be talking about that. Then there is a update called as orthogonal header content, which is divided into multiple categories A, B, C, E. It kind of replaces the end-to-end TLP prefix that we used to use in Gen 5. I mean, end-to-end TLP prefix was used more for processing hints, and routing information was being kept in TLP prefix, right? So now that has been moved into OHC, orthogonal header content. So we'll be understanding the format of OHC in type A, type B, type C, and type E categories, and how that is going to impact the TLP format also will be understanding. We'll also understand address translation services. I mean, how the device or the function uses the address translation services to translate the virtual address to physical address and update in its cache, and also address invalidation request. I mean, anytime some page table updates happens, how the invalidation happens, all those will be understood as part of address translation services. Then also we'll understanding about routing rules. I mean, how they have changed. You see, mostly our focus as part of this training will be to understand how things have differed and what are the new things have been added in Gen 6. And then we'll also talk about TLP processing hint rules for both flit and non-flit modes. Then we'll talk about processing hints and the concept of steering tag. uh, okay, so it's talking about steering tag. Generally it is useful in a uh, in a in a system where you have multiple PCI Express domains. So when you have multiple PCI Express domains, there could be matching bus device function numbers in the two domains. You could have two domains where both of them have the matching bus device and function number. So that is where the concept of steering tag has been introduced. Then you have got further updates in transaction layer are like we'll understand how the different header formats have been changed in Flit mode, and the TLP prefix processing for both local and end-to-end TLP prefixes. We'll also talk about process address space identification concept. Then we'll talk about the segment ID. Okay. Segment ID is also the same thing as one of the things I talked about, steering tag. It is similar to that. In fact, this is the one which helps us identify between the different domains of the PCI Express in the system. Okay. That was the wrong thing about steering tag. Tag is more like to direct the packet in the right to the right function, virtual function. Okay. Then we'll be talking about data link layer updates, where we'll be talking about the concept of shared credit pooling that has been introduced in Gen 6. We'll also talk about the updates that happened to the DLCM SM state machine. We'll talk about DLLP rules and DLLP type encodings. Few new types of DLLPs have been introduced, notably NOP DLLP, NOP2 DLLP, no operation to DLLP, and link management DLLP. So we'll be talking about DLLP encoding changes like NOP, NOP2, and link management DLLP. Then we'll also talk about data link feature DLLP. This is something which we have already seen in Gen 5. And we'll also talk about briefly about power management DLLP. Okay. These are the majorly the updates in data link layer. We'll also further talk about physical layer updates like what is Flit mode, the concept of L0P, L0 partial, where it gives us a provision where the link, without even moving out of L0 state, it continues to stay in L0 state, where it keeps itself in a partial state. Where not all lanes will be active. Some lanes will be kept into electrical idle, some lanes will be active. So that is why we are calling it as L0 partial state. We will also understand how L0 partial handshaking is done using link management DLLP. Then the concept of L0S has been removed in Gen 6 in the Flit mode. Okay. LTSSM updates. We'll also talk about what exactly is this 1B encoding or scrambling. You will understand that you don't do any encoding, actually speaking. That's why we are calling as same 1 bit is kept as 1 bit. But of course, we do scrambling. Okay. So here this term of encoding doesn't have any meaning because we don't do any bit changes as such except for scrambling purpose. So the whole purpose is, you see, in Gen 1 we were losing 20% of the bandwidth. In Gen 3 to Gen 5 we were losing almost 1.5%. How? 128 by 130B encoding. When we do, we are losing almost 1.5% here. So the 1B by 1B is done to even get away with that 1.5% loss we are getting in the encoding. Okay. So that is where we go with 1B by 1B encoding. So then you may ask, how do we identify between the data block and order set block the way we used to do in Gen 6? So all those things will be understanding as part of this physical layer updates. We will also understand what are the valid encodings for order sets, and how order sets are processed at the 64 GT per second. How does the receiver identify between electrical idle order sets, electrical idle exit order set, the fast training sequences or skip? No, fast training sequence won't be there in Gen 6 Flit mode because the Flit mode doesn't have L0S state, so there won't be any fast training sequence and skip order set. All those things will be understanding. Then we'll also understand the concept of Flit mode identification. Then when we move to 1B by 1B encoding, how the symbols are placed on the different lanes. Then we'll talk about the Flit mode transmit and receive side operations. Then we'll also understand how the alignment happens at block and Flit level for the 1B by 1B encoding. Alignment means how does the receiver identify that block is starting now the Flit mode is starting. So that how does that alignment happen, we'll understand. So it goes through various phases: unaligned phase, aligned phase, locked phase. So there are different phases. We'll understand all those things. Then we'll understand one other important update called as gray coding. Gray coding is a concept, right, where you come up with a pattern where the data changes only one bit changes from one pattern to the other pattern. So we'll try to understand what is the significance of that one bit changing in Gen 6 as such. Okay, I mean here, when we do the gray coding of the data pattern, from one pattern to other pattern, only one bit changes. So we'll understand more detail about gray coding, why it is done. Then we'll also talk about DFE, that is decision feedback equalization, that is used at the receiver end of the link. And we'll also talk about the concept of pre-coding and how pre-coding helps reduce the burst of errors. We'll be talking about that. And further to that, we'll be talking about how data stream is sent in Flit mode. Okay. The We'll talk about the forward error correction. I mean how 6 bytes have been introduced into each flit for for doing the correction of the any errors. I mean uh, the whole data is divided into 3 blocks. Okay, for correcting each block there have been 2 bytes have been added, so totally 6 bytes have been added. So how these 6 bytes help do the correction of the errors in the incoming fleet will be understood as part of the FEC. Then we'll also understand what are the rules for TLP bytes in the fleet, and we'll also talk about DLP bytes in the fleet. As part of that, we'll be understanding what is fleet uses, what is prior fleet was payload. I mean, these are the different fields. In fact, I mean, I would rather just mark them here. These are the different things. Means DLP bytes have a field called as flit uses. Prior flit was payload. I mean, the significance of all these fields will be understanding the type of DLLP payload, the replay command, the flit sequence number, DLLP payload, the optimized update flow control, the flit marker. So all these aspects which are part of the DLP bytes will be understanding this. And we'll also have field called as flit type, which will indicate what type of flit is it. Is it idle flit, no operation flit, or payload flit? And we'll be going in depth of each of them, like what exactly is the flit marker. Okay, basically it's a marker for poison TLPs. Okay, we had a concept of EP, right, in Gen 5. The similar thing is the flit marker here. Then we have got, or you remember we had end of bad packet EDB. The similar thing is the flit marker here. Then we'll understand the concept of implicit sequence number flit and the explicit sequence number flit. Then we'll take an example of flit mode to understand all these concepts. I mean, we'll take a few back-to-back transmitted flits to understand how these different fields and concept of implicit and explicit sequence number flits are used. Then we'll also understand transmitter and receiver variables and buffer in the flit mode. Then concept of flit sequence number and retry mechanism. Okay, I mean, anytime flit gets corrupted, you need to retry. So how does it work? I mean, how does it differ from Gen 5? In Gen 5, we used to retransmit the TLP. So here we don't have a concept of TLP retransmission because everything is transmitted as a flit. So flit here stands for flow control unit. It is a fixed size 256 byte fixed size uh, packet. I mean, which will consist of a TLP, DLLP, and the CRC and the forward error correction 6 bytes code that is collectively adds to 256 bytes. So we'll understand what exactly and how that retry happens. Then we'll also understand flit sequence number rules at the transmitter and the receiver side. And then further to it, we'll be understanding the physical layer updates, handshake phases. I mean, it goes through various handshake phases like idle flit handshake phase, the sequence number handshake phase, the normal flit exchange phase, and this is where all the flit transfer happens. Then we'll also understand the receiver received ACK-NACK processing, and ACK and NACK and discard rules we'll be talking about. Then we'll be talking about how the flit replay scheduling happens. We'll also talk about flit replay transmit rules, the flit ACK-NACK replay example. I mean, the overall example to understand when some flits are transmitted, how the acknowledgement and NACK are issued, and when the replay will be scheduled. All those things will be whatever we have learned here. All those things will be summarized in this example. Okay. Then we'll also understand what are the ordered set updates that happened in Gen 6. like with respect to addition of a new order set called as TS0, modified TS1, modified TS2. Then we'll talk about EIOSQ sequence. EIOSQ mean SQ here stands for sequence. Then concept of half scrambling. Then we'll also understand the equalization updates that are done in Gen 6, the clock tolerance compensation concept. Then we'll also talk about alternate protocol negotiation, though it is there in Gen 5, but we'll also talk little more detail in this training. Okay. Then the concept of retimers will also be understood. Then we'll talk about the power management updates in Gen 6. Then we'll talk about message TLPs, a detailed overview. In Gen 5, we haven't gone deep into each type of message TLP. Here, we'll be talking about message TLPs in detail. We'll also talk about extended capability structure. I mean, in Gen 6, we have only taken a brief about different types of capability structures and extended capability structures. So here we'll be talking in depth of the capability structures. Okay. We'll also talk about interrupt handling in detail. So this is a brief of what we are going to cover as part of the Gen 6 protocol training.